Okay. So these first problems say describe how to transform the graph of the monomial function x to the n and blah blah blah. Sketch it. Don't do that part. So number 4, g of x is equal to 2/3 times x minus 3 cubed plus 1. So what is happening to this graph?
It's going up 1, left, no, right 3. Right 3. Right. And it's compressed. Not an idea.
Yep.
Oh, sounds like all you.
Alright, number 6, g of x equals 3 times x minus 1 to the 4th minus 2.
Okay,
So down to stretched. Wait, it might be reflected.
it's not
No,
real.
it's
It's
not.
Wait.
Then it goes
It's
right.
Is it
right
equal sign?
It
one.
goes right one, yeah.
I couldn't
That's
tell if that
it.
was the equal sign or like negative because I'm
Those
wrong.
make me so happy. Those are my favorite problems we'll always do. Like, always. They'll always be.
Yeah, but I never understand the directions, and I usually try to solve it, and then I get confused.
What are the directions for this section?
Describe how to transform the graph of an appropriate monomial function f of x is equal to x to the n.
Okay.
So if you're transforming it, that means you're moving it. So you have to know how you're going.
There's a lot more to their instructions, but that's the only part we do.
Okay.
Alright. Describe the end behavior of the polynomial function, the limit as x approaches infinity of f of x, and the limit as x approaches negative infinity of f of x.
Lovely.
Number 26.
I don't know what that means. Oh, we went from 6 to 26?
F of x is equal to negative x cubed plus 7x squared minus 4x plus 3. So it asks us for, I'm going to set them both up and then I'm going to talk about how to get them. As x approaches infinity of f of x and the limit as x approaches negative infinity of f of x.
You know, I remember looking at when you were doing this in calculus when I sat there and you're both thinking, I never want to do this.
This is way easier than what they were doing.
Well, I know, but it has the word limit in it.
These are way easier than they look.
Is it gonna be an ordered pair?
No.
Yeah, I had no help then.
Neither am I. I have no idea.
Alright, so what we're doing when it asks for the limit, okay, as x goes out to infinity or negative infinity, okay, so on the x-axis as it goes out really far to the right and really far to the left, we want to know what's happening, okay? The only thing we need to be concerned about with a number that's that large, okay, so a lot of times I'll plug in like 500 or something like that when I'm thinking about this, is this first term right here. That's all that matters. Okay, the biggest powered term. I shouldn't say first term. Biggest powered term is all that matters. Okay? So I'm essentially going to take this one, the limit as x goes to infinity. So I'm going to imagine x being 500, and I'm going to say negative 500 cubed. That's going to be a really, really big number, right? But it's negative. So the answer is negative infinity.
Oh wow.
So you could just put any number in there?
Yeah, something that's really big. Like 200 or above.
So
I just always imagine 500 because then it's actually
So it's
pretty
going, if
drastic.
it's going to negative infinity, you plug in a negative number?
Yep, so I'm going to plug in negative 500. So negative 500 cubed is still negative something something. Okay, it's going to be an infinity number because it's going really big. And then times a negative,
Positive.
it's going to make it positive. So, infinity.
Oh, that was
And they won't always be opposite, so don't always assume that one answer should be negative and one should be positive.
So,
Because
is this
it's
all we
exact.
gotta learn for
No,
this?
my eyes watered.
Yeah, I'm feeling this is pretty good.
I like this.
Alright, so we got the shifting and then the infinity stuff, and then we're done with this. Yay.
Oh, there's more to this section.
Okay.
F of x is equal to x cubed minus x to the fourth plus 3x squared minus 2x plus 7. Okay, so same instructions.
It's negative x to the fourth is the base.
Okay, yeah, so I'm going to be looking at... I'm going to be looking at the negative x to the fourth now because that's the highest power. So if I plug in something like 500, okay, it's going to become negative. So it's going to be negative infinity.
You're looking for the highest power, right? That's where you plug it up. Okay.
Then if I put in negative infinity,
They're both negative. It's gonna be negative.
okay, that one's also going to be negative because it's to an even power. That's going to make the negative 500 that I'm plugging in become positive, but then there's still a negative out front. So these both are going to come out to be negative. Easy enough.
Yeah.
Not as bad as what I make them do in calculus.
Oh, no. But I still know that
I'm not going to talk you into calculus like I talked you into this one.
Yeah, no.
All right, 34. Find the zeros of the function algebraically. F of x is equal to 3x squared plus 4x minus 4.
Oh. So you're doing the quadratic
Not yet.
Is this the same directions or no?
I don't think you have to.
Yeah, you
can do No.
2 and 6.
This is find the zeros of the function algebraically.
Technically, I think
So I'm going to factor.
Yeah.
So what does...
Can't you do 2 and 6?
Yeah, you need a positive 2 and a negative 6, and then you're good.
So I'm going to do 3x squared plus 6x minus 2x minus 4. Whoa.
Never mind. Switch the things I said because I was looking at the other 4.
Yeah,
when I
it was
said that. My bad.
Oh my gosh, it's December 1st. So close to my birthday.
I know.
29 days.
I have an advent calendar with chocolate in it. That is so nice. I forgot to open it today. There's a little chocolate candle. It's cute.
All right, so what can I pull out of the first two? What's my greatest common
3x.
factor?
3x.
3x times, or x
plus
plus
2.
2, and then over here.
Negative 2, x plus 2.
And then you're
So
really
these
last.
two match.
Minus 2 and x plus 2.
And then you set them equal to 0, don't you?
Yep, I'm going to set each piece equal to 0.
Oops, that's not how.
I don't understand how there's so many different directions literally just to do the same exact thing we've done. Like,
So they're trying to combine them together. They're trying to make you try to like figure out words in this
Well, that's
process.
the
They try to make you hate math even more than you do.
well, it's working. So, congratulations.
Is that the answer? Sweet.
What did you guys do yesterday?
You can go watch the video. I posted it.
I didn't have my
Because there's
phone,
homework
like,
due tomorrow for you for that section.
I have it. I didn't have my phone. My mom took it yesterday.
Well, better figure something out.
Watch it tonight then.
All right, 36, same instructions. F of x is equal to x cubed minus 25x.
Wait, is this like a special one?
It will be, eventually. What's in both pieces that I can take out?
Can take one out.
So x times x squared minus 25. Now what is, this is a special type.
And then
Minus
it's
5.
x times x. Wait. Is it the?
Isn't it just like x plus 5, x minus 5?
Yeah. This is one of them, and then I like bring 5.
I'm just saying today in English I'm gonna fall asleep because we're gonna be reading a book.
Do I?
It's a good book.
Is that a pickup at the youth house after school?
The
It's in the
movie's
gym.
good. I don't know about the book though.
All right, so set each piece equal to 0.
My mom worried me.
So
X equals 0. Oh yeah, you already did it.
And then x equals 5 and negative 5. And you're like, yay.
Wait, what is X?
and they all need to be written separate. Okay. They're not going to all be the case at the same time.
I like this. Next.
Dang it, I forgot to write or.
I did too. They're all kind of squishy.
All right. State the degree and list the zeros of the polynomial function. State the multiplicity of each zero and whether the graph crosses the x-axis at the. I'm not worried about that part.
What's multiplicity?
We'll figure out which does first problem. Make sure you forget it.
Oh, it's right there.
If a polynomial function f has a real zero c of even multiplicity, then the graph of f does not cross the x-axis, and if it has an odd multiplicity, then it does cross the x-axis. The multiplicity of a zero of a polynomial function, if f is a polynomial function and x minus c to the m is a factor of f, but x minus c to the m plus 1 is not, then c is a zero of multiplicity m of f.
I'm
So,
sure that'll make more sense when you actually do it.
it will.
Okay. I never understand the notes, and then when like we do all the problems and I go back and read the notes, I'm like, oh my gosh, it makes so much sense.
Alright, so 40 f of x is equal to negative x cubed and then x minus 2. And so basically, what we're doing here is we're going to find to find the degree, we have to find the highest powered x, but right now that's not super, well, it is evident, but it's not because it's not written there. We need to do something first to find it. Yeah. And then ultimately we're going to set this equal to 0 and solve for it. So you don't actually have to show the step of distributing if you can just tell me what the degree is without doing that. Okay.
I did it.
So the degree is 4. If you want to rewrite it, multiply it out, you can. But you're going to need it in this form to do the zeros and all of that. So it doesn't really matter. So based on that, I don't even care if you show the work for this part. What are my zeros? This one's easy enough. You don't need to.
X cubed. Wait.
Set each piece equal to 0.
Wait a minute. Not that. Wait. Give me a minute.
Negative
Wouldn't it just
0.
be 0? 0
So
and 2?
x equals 0, x equals 2.
Really? I can't focus.
Why would it be 0?
So because negative x cubed equal to 0 is just 0.
Why isn't it
Like the square
negative
root.
2? Oh.
Because you set them equal to 0 and solve for x. Alright, so then what multiplicity means is how many times does that 0 occur?
1. Oh, 3 is 4. I don't know.
Okay, so negative x cubed equal to 0. Okay, that occurs 3 times. Okay, because its power is 3. So its multiplicity for the first one is 3. The second one, there's only one x, so its multiplicity is 1.
So it's basically just on whatever the exponent is.
Yep.
Is that it?
I mean, we're doing another problem, but yes,
No,
that's all you have to do for that.
Yeah.
To keep like holding my sweatshirt because right now it's plugged into like a non-Apple charger, and so it like causes it to like freak out if my hand is like on the iPad. Really irritating. All right, 42. F of x is equal to 7 times x minus 3 squared, and then times x plus 5 to the 4th. Okay, so now in reality, you probably aren't going to want to multiply this all out, but you really don't need to. Okay, if I just have a value in here, okay, when I FOIL it, what's the biggest x value that I'm going to get? X squared. Okay, and then in here, what's the biggest I'm going to get if I'm raising it to the 4th? Okay. Now, don't get confused and think that, oh, it's just x to the 4th plus 5 to the 4th. Okay, still remember, if you were actually multiplying it out, you'd have to multiply it out. But for the purpose of finding the degree, that's all you need to do. So then you'd have x squared times x to the 4th, giving you x to the 6th. So what would my degree be? 6.
Okay, so you add your exponents, or I mean, yeah.
Yes, because it'd be x squared times x to the 4th.
So you.
Because these were being multiplied.
Okay, so only when
Oh,
they
everything's
multiply it.
I was kind of confused.
All right, so then what are my zeros?
So 7 equals 0.
Well, okay, 7 equals 0. That's not a true statement. So
X equals 7. Negative 7.
there's no x with the 7.
Yeah,
X minus 3
distribute first,
equals
right?
0.
Because if you set this whole thing equal to 0, okay, then because all this is being multiplied, I can go ahead and just divide by 7. So that's going to just go away. So then I'm left, so that's gone. So I'm left with x minus 3 squared times x plus 5 to the 4th.
Is it x equals 9? 3 squared.
No. Okay, so we have x minus 3 squared equal to 0. And I'm going to have x plus 5 to the 4th equal to 0.
Oh, you'd have to take the square, so it's going to just be x equals 3.
Okay, so I'm taking the square root first. So x minus 3 equals 0. So x equals 3 is one of them. And then with this one, x plus 5 equals 0. So x equals negative 5. So then multiplicity, okay, I want to know how many times they occur. Okay, the first one occurs twice.
I don't understand.
It's how many times, basically the exponent.
Whatever this exponent is,
Oh, I'm sorry. I was.
that's on
I
it
didn't
is the
understand
multiplicity.
it until just now, but I got it. I'm feeling smart.
All right, one last problem.
Why am I feeling?
All right. Using only algebra, find a cubic function with the given zeros. Support by graphing your answer. No, not that part. Okay, so 54, you are given the zeros negative 2, 3, and negative 5. Negative 2, 3, and negative 5. All right, so these are the zeros. Okay, so these are what's written up here. So the way I like to rewrite and think about them as x equals negative 2, x equals 3, and x equals negative 5. Okay, because I'm trying to find a cubic function. Okay, that means I have the 3 zeros. I'm going to move all of those from the right to the left to get x plus or minus something to make my parentheses. Okay?
So it's x plus 2 times x minus 3 times x plus 5.
Okay, so all of these things are what would have been in parentheses. Okay, now we're kind of undoing what we did. So up here, we had those, we set them equal to 0, we solved down to x. So now we're working our way backwards. Okay? Huh? These ones, it doesn't because it not the,
Do you just like superfoil them all?
yes, we're going to ultimately superfoil. Because you see how we had these two things here and they were being multiplied together. We set them equal to 0. So we're undoing this. So we're going to take and we're going to multiply, say f of x is equal to x plus 2 times x minus 3 times x plus 5. And then we're just going to superfoil. Now, obviously, one other thing I want to point out, if you don't put this in your answer, it's fine, but I just want to point out, See how in number 42 there was a 7 in front and then it just disappeared because of setting it equal to 0? In technicality, we don't know if there was a number out here or not. So what sometimes your book may put it there, I'm not sure. Sometimes they'll put a K out there to represent that there's a constant value that could be out there. But again, if you don't write that, like, that's fine. Okay, I'm just letting you know that there could be a constant there. So now we're just going to superfoil this. So what does that give you?
X squared minus 3x plus 2x minus 6. Times x plus 5, sorry. I kind of forgot that part.
So then
X cubed minus 3x squared.
hold on, simplify this stuff first.
That would probably be a lot more helpful.
And then now superfoil.
I have to write it down somewhere. Minus x squared minus 6x
Forgot how to foil.
plus
Forgot to do
5x
it.
squared minus 5x minus 30.
Oh, I think you're
And then simplify that, so it's x cubed plus 4x squared minus 11x minus 30.
Yay!
That's not even that hard either.
Okay, and like I said, had there been a constant, what we would have done is just written it like this, but it didn't tell us if there was or not, but that's just how you would account for that if there was, but I don't care about that part. I'm just letting you know for reference. All right, so your problems: 3, 5, 25, 27, 33, 35, 39, 41, 49, and 53.
These are due Friday.